not this one. Yeah, so 2.2. So 2.2 is just yeah, so 2.2 just introduced the I think 8 basic functions. I mean, I think 7 basic functions and one just relations between x and y. Okay, so and then their graph and range, domain range. Okay, so maybe it's kind of boring, but please memorize all of the what functions and relation between x and y and their graph. Okay, because we're gonna use them in 2.3. Okay, so 2.2 is what the graph, right? And their functions. Okay, so objective. So the first one, yeah. So yeah, I'm gonna just delete the functions and then a relation introduced in the 2.2. Okay, so the square function, just say ft. That means function. Okay, uh, the um, the definition of square function is this: f of x is equal to x squared. Okay, so you saw that, right? So we know that the graph of x squared is a parabola, right? And then the second one, the square root function. Okay. Um, and the definition of the square root function is f of x is equal to square root of x. Okay. Then third one, the q function. And I covered this one last time, right? X cube, right? Okay. Well, now on the x squared and x cube, I also introduced the power function x to the nth power. N is even and n is odd, right? Remember that. So then for the cube root function, okay. So the f of x is equal to the cube root of x. Okay. And the 5, the semicircle. Okay. Yeah. Semicircle. The equation of semicircle is a function. Okay. But there are two semicircles. Okay. So upper semicircle, the lower semicircle. Okay. Okay. So what does that mean, upper and lower? Yeah, I'm gonna cover this one later. Okay. So anyway, this is a function. Okay. These are a function. Okay. And then 6. Yep. Cube root and the semicircle and the absolute value function. Just ABS means absolute value. Absolute. Okay. Absolute value function. Okay. The f of x is equal to absolute of x. Okay. Next one is 7 is this is not a function. The parabola opens up, opens to the right. Okay, so that's the this y squared is equal to x. Okay, so why this is not a function? Because yeah, see, think about this. When y equals 2, when y equals 2, okay, sorry, not this one. When y equals 2, think about this. Think about the what value of x must be to be that y is 2. You know, so to get 2 as a y value, then x must be about 4, right? Makes sense. Because 2 squared is 4. Okay. But also, -2, when y equals -2, we're gonna get 4, right? As x value. Okay. So we have two order pair have the same first, different second. Okay, that's totally violation of the definition of function, right? So this is not a function. Okay. So that's why you use the letter y instead of the function notation f of x. Okay. Excuse me. So now, one, two. Let me see. Let me check if there is more other one on the this section introduce. So I think that's it. Cube root, and semicircles, and yeah, piecewise function. Yes. Yeah, I think I forgot piecewise function. Yeah, 8. The piecewise function. Okay, so basic. Yeah, there are tons of the different definition of piecewise functions there, but let's see this one. F of x is x and negative x. Okay. If x is greater than or equals 2, and then if x is less than 2, something like this. Okay, so, or yeah, something like this. Okay, so what does then piecewise function? Piecewise function is this definition of function defined for each different number. Okay, so anyway, let's start from the square function right here. Okay, we did that, right? So let's start from the square function. So last time I covered the square function and the q function, right? So I'll skip the 1 and 3, okay? And I'll start from the second objective, square root function. So the square root function, the second one. So f of x is equal to square root of x. Okay. So the graph is this. I mean, just take a look at this. I think we haven't seen this kind of function before, but I told you square root of something is always what, greater than or equal to 0. Okay, so then we expect that what, the f of x, I mean y value, never can be, there will be a negative number, right? Because square root of something is always greater than or equal to 0, so range must be 0 to infinity. Okay, so that's why I didn't draw the, see that negative line in the y-axis. Okay, so anyway, the graph of this guy must be like that. Okay, I mean that doesn't decrease. Okay, it's increase y values increase x as x value increase. Okay, so it never goes down or drop. Okay, keep in mind this is increase. So and then you see the x is a quantity under the square root, so that must be greater than or equal to 0, right? Because we only deal with the real number, right, in this section. So the x must be greater than or equal to 0, because if x is less than 0, then we're going to get a complex number. We do not deal with a complex number in this section. Let's keep like this. So here's a 0. Okay. So now domain, here the domain is what? The domain, let's be what? That's going to be 0 to infinity, right? And the range is going to be 0 to infinity 2. Okay. Then the 2, 3, 4, the cube root. Okay. Cube root function. Function definition is this: cube root of x. Okay. Now here x can be a negative number. Okay. So, I mean, think about this. Why here in here x must be, must be greater than or equal to 0. Why? But here x can be a negative number. I mean, x can be any real number because that's basic algebra stuff. But what's the definition of square root? What's the definition of cube root? I know some of you maybe forgot about that. So let me remind remind you of that one. Okay. So think about this. X squared is equal to 2. Okay. So here, I want to find out solution of this equation. Okay, can you see that? Okay. So now x squared is equal to, then solution of this equation is what? Actually plus minus square root 2, right? Okay. Okay. So plus square root 2 minus square root 2, right? So, so square root is actually 2. This is what? Solution. Here root means solution. So square root of 2, that means what? Solution of that equation. So in general, x squared equals a here, and the square root of a, actually plus my sign. Plus minus square root of a means that solution of that equation, x squared is a. So the square root of a means the solution of the equation x squared is equal to the quantity under the square root a. Okay. So now then think about this. Then what? The here x squared equals a, x squared equals a can be negative number? No, a cannot be a negative number because it's square. See that x squared for any real number for x, taking square always return positive number, right? When x equals 0, we're gonna get 0 as a value, but that's why a must be always greater than or equal to 0. Okay. Now then, what about this? X cubed is equal to 2. Then what's solution of this? Okay, this is gonna be, you may say the plus minus cube root of 2, but that's wrong. Okay, it's not right. We have to drop the negative sign. Why? Because negative cube root of the square to the cube. Okay, let's say, you still claim that negative cube root of 2 is a solution of this equation. Then okay, I'll plug in negative cube root of 2 into the equation x. I mean, then what happened? Negative cube root of 2 cube to the third power going to be what? Negative cube root of 2 times negative cube root of 2, right? Times negative cube root of 2. Then you see that we multiply negative sign 3 times. Okay, 3 times, then we're going to get still negative sign, and then 2. That's not equal to the number on the right hand side, right? So in the other powers, the negative sign will be reserved. Keep in mind this. Okay, so we have to drop the negative sign. So plus cube root of 2, this is the only solution of that equation. And then generalize this, then we got this x cubed equals a. Then what's the solution of this? Just cube root of a. Okay, why is cube root of a? That's the definition. Okay, so that's the definition. Okay, we what declared that. Okay, mathematicians declared that. Okay, the meaning of this symbol, when they develop created this symbol, they just say, let's say this is the way to express solution of that equation. Okay, so now you see that then a can be a negative number. Still you don't get it? Let's say, let me give you one more example. X cubed is equal to negative 2. Okay, then what's the solution of this? Yeah, by the way, the something number cube can be negative number? Yes. For example, negative 1 cube is negative 1, right? Negative 1 times negative 1 times negative 1 is negative 1. So likewise here, the number on the right hand side in this equation can be a negative number, and the solution is what? Negative cube root of 2. Okay. So now, so back to here, so x can be a negative number, and then graph must be like that. Like this, and like this. Okay. So in the textbook, they what? Let's see. When you take to look at textbook, they give the example. I mean, the specific some of the ordered pairs on the graph. Okay, so the for example, let's see. Um, think about this. Here's 27. 27. Okay, 27. Then what is the y value cross by 27? Just 3. Okay. Well, how come? Because cube root of the 27 is equal to what? The 3 cube. 3 times 3 times 3 is 27. 3 cube to the cube root is nothing but exponent 1 there. So we got 3. So if you don't get it, what I'm doing here, yeah, please review the basic algebra stuff. Okay. So now, what about the negative 27 here? Negative 27. Then is what? It's going to be negative 3. Okay, negative 3 is the y value corresponding to negative 27. So as you can see that domain is what? Negative infinity to infinity. And the range is going to be what? Negative infinity to infinity. Okay. So here domain is yeah, negative infinity to infinity, and the range is negative infinity to infinity. Okay. So just you see that here, the square function and the cube root function in the graph and domain range are totally different. Okay, keep in mind that. Okay, totally different. So now we cover 2 and 4, and then let's see 5. The semicircle. Okay. So let me derive the what definitions of functions of semicircle. Okay. So we start from the circle whose center point is 0, 0. Okay. So this is a radius r. R can be, give me a second. It's blurry, right? Focus this on. Okay. All right. So now r here in the center point is 0, 0. Then equation of the circle is what? X squared plus y squared is equal to r squared, right? So now think about this. To get function, what? To get the what definition of function of the circle. I mean, semicircle. We want to find a semicircle eventually, but to get that, we just isolate line. Okay. You see that here, in the function definition of square root function and the cube root function, f of x equals something, f of x equals something, right? So you say f of x is nothing but y value, right? F of x is nothing but y. Okay, so we need to isolate y first. So I'll just subtract x squared on both sides. Okay, so y squared is equal to r squared minus x squared. And then, to get y, just y, in the left-hand side, we take a square root. Okay. Then we're going to get y is equal to, and then we apply the square property. Remember that? I think 1.4, right? So when you do, when I cover the quadratic functions, you really learn the square root property, right? It means that when you take a square root on both sides, you have to put plus minus sign on one side. Okay, so plus minus the square root of r squared minus x squared. Okay, so see that, what does that mean, plus minus? What's the meaning of plus sign and minus sign? Negative sign. So definitely this is not a function. You see that the relation between x and y is not a function. Why? Because for for a given, for any x value, it should this value should be assigned with only one unique y value, but this is the plus minus sign, right? For example, when x equals 1, you plug in 1 into x, we're gonna get two distinct y value. So that's not a function. Okay, so we just separate them. Okay, So y is equal to plus sign and square root of r squared minus x squared. Then y is equal to minus square root of r squared minus x squared. So this one actually represent the function of the upper semicircle, which is this. It makes sense. Why? Because for for all of the x value, their corresponding y value must be positive because the graph lies above the x-axis, right? Okay. So, and then you see the square root of something. I told you square of something is always greater than or equal to 0. Yeah, makes sense. So this one must represent the what? The function of the upper semicircle. So this is the function of the upper semicircle. Okay. So what about this? Guess what? This one is function of what? Lower semicircle, right? Hmm? Okay. So this part right here. Okay. Glory. Still same. All right. Now, give me a second. What? Okay. All right. So now, upper semester, lower this is lower semester, right? This is upper semester. Okay. So now we're gonna use f of x or any other function notation instead of y. Okay, you can use that. Okay. And then domain range. The upper semicircle. Give me a second. Upper semicircle. Upper semicircle. The upper semicircle. The domain is what? Domain gonna be what? Negative r to r. Is it here negative r? This is r negative r, isn't it? Okay. So the actually x x value possible x value is restricted by negative r and r, right? Because x value cannot be exceed the negative r to r. Okay. Can you find out? I mean, because the graph of you see the circle cannot just doesn't go to infinity or negative infinity, right? So domain must be negative r to r. Okay, this is same. I mean, the domain of the lower semicircle is same as the domain of the upper semicircle. See, even the lower semicircle, the domain is what negative r to r. Okay, so okay. Then what about the range? Also, range. I think about this y value in the upper semicircle. Y value is 0 to r, right? So here's 0 in the r. Okay, the range is what 0 to r, not 0 to r, negative r to 0. Okay, you see. So keep in mind this upper semicircle, lower semicircle. Okay, r squared minus x squared. Why is it r? It all depends on problems. Okay? And then now what is this? Oops. Okay, let me do it here. So yeah, let's see. This one. 5 and 6. The absolute value. So the absolute value function is this: f of x is equal to absolute value of x. Okay. So now the graph of the absolute value function is this. Okay. But actually, absolute value function is one of the special case of the piecewise function. Why? Because by definition, I mean, applying the definition of absolute value into the definition of function, then we get this x and negative x. And then if x is greater than or equal to 0, and then if x is less than 0. So f of x has a multiple definitions. depending on the interval on the x-axis, right? So if x is greater than or equal to 0, what does that mean? X is greater than or equal to 0. It means that expressing this inequality in interval notation, we got this 0 to infinity, right? So on this interval on the x-axis, f of x is defined by x. Okay, so what is this? 0 to infinity here, right? 0 to infinity is this. You see that? So 0 to infinity on that interval, the function definition is what? F of x equals x. But I told you the function notation means nothing but y, right? So this is nothing but what? Y equals x. So what's the graph of y equals x? This, right? Y equals x. Okay, y equals x. This is y-axis, by the way. Okay. Then what about the x is less than 0? In interval notation, that is what can be expressed as what? Negative infinity to 0 and open, right? So negative infinity to 0 is what? On the x-axis, this. Okay. So now, then on this interval, f of x is defined by negative x. Okay, so f of x is equal to negative x. It means that y is equal to negative x. The graph of y equals negative x is this. I know actually graph of y equals x is this one, right? This one. But what the y equals x. I mean f of x defined by x, not entire x axis, but just 0 to infinity. So I cut this part. Okay, I cut this part. Same goes here. Okay, so y is equal to negative x. Anyway, so that's why the graph of absolute function is like this. Now see domain. Guess what? You see that x can be any number between negative infinity and infinity, right? Okay, so domain gonna be is equal to negative infinity to infinity, and the range is gonna be what? Range is what? 0 to infinity. It's obvious, right? Okay. So, but here's a question. You may just wondering, what about this? F of x is equal to, yeah, maybe just 5 times attribute of x. What's the graph of this guy look like? Yeah, this is what we're gonna cover in learn in 2.3. Okay, this is one of the family member of the absolute functions. Okay, but the answer is this: the y-axis and the x-axis. See, the width between two straight lines gonna get narrower. Okay, so like this. Okay, for this one. Okay, 5 times. How come? Because think about this. When x is 2, let's figure out the order pair whose x coordinate 2. So when x is equals 2, we're going to get 2, right? Okay. But we're going to get different y value, actually bigger value for y value when x is 2 in here. X is 2. Then when plug in 2 into x, we're going to get 5 times 2, which is 10. Right? Okay. For each same y value, for each y value, we're gonna get the 5 we're gonna get a multiple of 5 actually, right? So bigger number than the numbers we're gonna get as y value here. Okay, here. So now yeah, I'm gonna talk about this one later. I mean 2.3. Okay, so not only this one, but what about this? Y is equal to, oh sorry, f of x is equal to for example negative 2 times x squared, or f of x is equal to negative 2 times x plus 5 squared plus 2, something like this. So we're going to study how to figure out the graph of this function by using the graph of f of x is equal to x squared. Okay, 2.3. So now next objective is the parabola opens to the right. So 7. Okay, parabola opens to the right. So y squared is equal to x. Oh, not x squared, but just x. So, okay, let's figure out the graph of, okay, graph of that region, okay? So when x equals 0 and then 1 and 2 and 3 and 4, okay? So I'm not going to give the graph, but let's figure out, okay? Let's just, um, try to figure out the graph by figuring out y value for each specific x value. So when x is 1, then to get 1 as x value, y value must be 1 or negative 1, right? So 1 and negative 1. So there are two y value corresponding to x value 1. That's the reason that this relation is not a function, okay? All right, so now when x is 2, then what? To get 2, y value must be plus minus square root 2, right? Because the square root of 2 squared is a 2, minus square root of 2 squared is 2, right? So is square root 2 is minus square root 2. Okay. Okay. Then when x is 3, what? Then we're gonna get square root 3 and then minus square root 3, right? Okay. So the graph must be like this actually. Okay. So this is actually graph of the parabola opens to the right. The parabola means this, like this. Okay. So this is called the parabola opens up. This is a parabola opens down. Actually, this is the these are graph of quadratic function, but we're gonna study in 2.4, right? 2.5, I think. Okay, 2.4 maybe. Okay, parabola opens. So this means the parabola. Okay, so parabola opens to the right must be this, right? What about parabola opens to the left? This one, right? Is it? Okay. So by the way, what's the equation of the parabola open to the left? You see? Okay. Then what? Y squared is equal to what? Negative x. How come? Yeah, we'll see. We're gonna see why this is the how we can get this one in 2.3. Okay. So last one is piecewise function. Yeah, we saw that the one of the specific example of piecewise function, which is absolute value function. Oh, sorry. By the way, we didn't get the domain range and parabola open to the right, right? So here domain must be what? Be 0 to infinity, right? And the range gonna be negative infinity to infinity. Okay. So now then, last one, piecewise function. Okay, actually not the piecewise functions. Okay. Example is this: f of x is equal to x. Yeah, so here in the objective, I just put x and negative x, but let me slightly change, not just x, but let's see. Give me a second. X plus 2. Okay, slightly change. Okay. So let's see, x and x plus 2. Okay. And then if x is greater than or equal to 2, and then if x is less than 2. Okay. Actually, I gave you how to plot the graph of piecewise functions when I covered the absolute function. First, we need to figure out what the inverse. Okay, inverse of this, inverse of this for each definitions. So x is greater than or equals 2 means that what? 2 to infinity. X is less than 2 means that negative infinity to 2, right? Okay. So now we divide the x-axis into two solid numbers, 2 to infinity, negative infinity to 2. Okay, so right there is a 2. Okay, so 2 to infinity. Okay, and then negative infinity 2. All right. Okay, So here on this interval 2 to infinity, f of x defined by x. So it must be what's the graph of f of x equals x? What graph of y equals x is what? This, right? Okay. So we're gonna cut this part out. Okay. So when x is 2, the y value is 2 right there. Starting from this point, okay, this is the graph of the f of this piecewise function on the interval close to infinity. Okay, so that's the part of the graph y equals x. Okay, we just cut out this part. Okay, now what about this on negative infinity 2? On this interval negative infinity 2, graph of the f of x must be what? Y equals x plus 2. Graph of y equals x plus 2, right? So y equals x plus 2. We plot this one, okay, using the using dot line, okay, and then we figure out which part do I have to cut out. So the graph of x plus 2 is what? This one. Okay, this part. How come? Because you know the what here what the slope of this line is 1 and the slope of that line is also 1. So these two lines are parallel, right? And then y-intercept is 0, 2 here. In this graph, y-intercept 0, 2 because 2, this is slope-intercept form, right? And the 2 means what? The y-coordinate y-intercept. So the what y-intercept of this line was 0, 0, 2 right there. So graph of this equation, I mean this linear equation, must pass through 0, 2 and parallel to that line, which is this. And then see, so now what? So the f of x is defined by x plus 2 only this interval. So we cut out this part. Okay, we cut out this part, so we got this right there. Okay, but by the way, so in that interval, 2 is not included, right? It's open, right? Because x is less than 2. X, that doesn't mean x is less than or equals 2, right? So x is just less than 2. It means that x cannot be 2. So here, open, this is called the open ball. Open ball means that the and the closed ball, right? The closed ball here. So open ball means that what y value is not defined at this number, at this the polar pair, this point. I'm sorry. Okay. So when x equals 2, y value must be 2, not the y value in here. No. Okay, that means open ball. Okay. So simply saying that open ball means that open interval and the closed ball means this is closed interval. You can say that. So graph must be like this. Okay. So this is a straight line. Okay, it looks different, but so the sometimes you will see a function with the not just two, not two, but more than two, three, four, five, multiple, you know, the definitions with distinct intervals. Okay, then you should be able to plot the graph of that piecewise function. The what I did here, okay, using the strategy what I did here. Okay, so now see, that's all the 2.2. Okay. Now we're gonna move to 2.3. Okay. So 2.3 is this. Let's see. The families of function, transformation, and symmetry. And symmetry. Okay. So give me a second. This. All right. So now, oh, oh, yeah. Um, so we know, think about this, square functions. So y is equal to x squared, or we can say f of x equals x squared. Yeah, right there. Okay. So say f of x equals x squared. Okay, the x axis, y axis. Okay. So now, the, I want to figure out the graph of this parabola. Okay, using the f of x squared. Okay. So let's say this graph of this function is g of x. What does the equation of this g of x look like? Okay, so the actually we can figure out the equation of g of x by transforming, actually shifting, kind of shifting this function to here. Okay, that's called transformation. Okay, transformation has the consists of three parts. Just shifting upward, downward. I mean the vertical um, translation, horizontal translation, and then stretching, shrinking, and then reflecting. Okay, so this three part. So translation, okay, and then yeah, stretching. Actually, stretching and shrinking vertically and then horizontally. But in this text, on this course, we're not going to cover. I'm not going to cover the stretching, shrinking horizontally. I'm going to cover only stretching, shrinking vertically. Okay. Okay. Here, stretching, shrinking means stretching, shrinking vertically. Okay. And then last one is the reflection. Okay. So using these technique about transformation, we could figure out the equation of g of x of this one. Okay. So, or if that equation is given, then we can figure out the graph of that function by using transformation, applying transformation into the graph. Okay, so that's the main objective of this section. So, and then objective. Okay, objective. So one is the actually, yeah, transformation. I mean, horizontal transformation. Let's say horizontal transformation. Normally, just say just HT. Okay. And second one, let me mention the vertical translation later. Okay. And then compressing, I mean stretching, compressing, or compressing, stretching, shrinking, it doesn't matter. Okay. Or it's just horizontal translation. You can say horizontal shifting. Okay. That doesn't matter. So stretching, stretching, and then compressing. Okay. Vertically. Okay. So then the other one, reflection. I mean, reflection has three type of reflection we're gonna study. Okay, so reflection about the x-axis, reflection about the y-axis, and then about the origin. Okay, so oops. Okay, reflection about the x-axis, y-axis, and origin. What does that mean? Origin 0, 0. The last one is a vertical transformation. Okay, it's VT. Okay, so the why this write down vertical translation at last, because this is the order you have to follow when you apply transformation, unless the problem give you specific other specific the order of the transformation. Okay, keep in mind this. You should apply horizontal transformation first, and then apply reflection or stretching. Doesn't matter. Okay, but um, yeah, normally we let's see. It doesn't matter here. Two and third, the order of two and three doesn't matter. Okay, so you can switch them out. Okay, so but HT, apply HT first, and then stretching, compressing vertically, and then reflection, and then apply the vertical transformation at last. This is all the key minus. But if problems give you the specific order of the transformation, you have to follow that. Unless that, you have to follow this order. Keep in mind this. So now, see that symmetry right there? Yeah, we're gonna study symmetry in the last. Okay, so okay, this is 5 symmetry. Okay, what does that mean symmetry? You know symmetry, right? So example is y equals x squared. Square function is symmetry. Symmetry means that the when you cut when you just fold the graph half and half by the y-axis. Okay, you just fold this part to this side, then their graph is just, identical. Okay, then we say that the function is symmetry about the actually y-axis. But okay, so the now let's see here, and then see that all of functions obtained by transformation are called the family of functions. So in this case, this is the what? The g of x. If you get the if you get the equation g of x by applying transformation into the square function, then these are actually families of functions, square functions. Okay. But nowadays, every single all of the functions they obtained by applying the transformation of the square function, then they are family members of the square functions. Okay, keep in mind this. So I'm going to introduce the HT and the VT, horizontal transformation and vertical transformation at once, and then see a couple of examples and then call it a day. Okay. So now, so transformation in first one HT, okay, and then VT. All right. Those so blurry again. Oh. It doesn't work. Mm. Oh, it works. Okay, so here, think about this is graph of the f of x. Okay, so and then if you want to move the graph to the right, I mean, okay, shift graph of f of x. Okay, shift graph of f of x um, to the right. Okay, okay, h unit. Okay, okay. So then what happened to the equation of f of x? then f of x will be changed to f of x minus h. Okay, so it means replacing x by x minus h. Okay, so now what if we move the graph of f of x to the left? Okay, so then shift the f of x to the left, h unit. Okay, then we got f of x plus h. Okay, so the what the equation function, I mean the function of this graph can be obtained by replacing x by x plus h. Okay. What about the upward and downward? If you just move the graph of f of x upward, okay, f of x, okay, upward k unit, okay, then we got this f of x plus k. I mean the function f of x will be changed to f of x plus k. Okay, and then shift f of x, graph of f of x. Okay, okay, let me just say f of x downward. Okay, k unit. Then we got this f of x minus k. Okay, so if you just memorize this kind of diagram, okay, if you memorize the diagram, then yeah, you can apply the HTVT easily. Okay, so let's see example. Let's see example in the textbook. Okay, so let's see. Yeah, so example one in textbook. Okay, so example one. Oops. So the question is this: graph f of x, the square root of x, the g of x, the square root of x minus 3, and then h of x, say the square root x plus 5. Okay, so on the same plane, xy plane. Okay, so we know graph of the square root of x. We learned in 2.2, right? That's why I told you memorize graph of the function introduced 2.2. So you see here is x-axis, here is y-axis. The graph of square root of x is this. This is the graph of f of x. Okay, x-axis right here. What about the square root of x minus 3? So to figure out the graph of the x minus 3, I mean g of x, then we try to express g of x in terms of f of x. Okay, so see, square root of x minus 3 and the square root of x. To get the square root of x minus 3 from the f of x, we need to replace x by x minus 3. So actually, g of x is what? This is equal to actually f of x minus 3. Okay, and now you see that replacing x by x minus 3, that's the way to move, I mean shift the graph to the right, right? Okay, so we move the graph of f of x to the right 3 unit, 0, 1, 2, and 3. Okay, so moving the graph to the 3 unit, that means what? That point also must be moved to the right 3 unit, right? So 1, 2, 3 right here. Then graph like this. This one. All right. So this is a graph of g of x. Or we can say this is a graph of x, f of x minus 3. Because g of x is nothing but f of x minus 3, right? Now, what about the x plus 5? Square root x plus 5. What? Same strategy. Yeah, h of x. That is equal to what? F of what? F of what? X plus 5, right? Okay, because I express square root of x plus 5 in terms of f of x. So we got this. Replacing x by x plus 5, it means that what? Shifting the graph of what? F of x to the left 5 unit. Okay, so 1, 2, 3, 4, 5. Negative 5 right here. Right here. Then graph is like this. Okay. So we got move to the 5 and then move to the right, and then 3, right? Okay, -5 actually. -5. Okay, so let's see one more example. This is example 2. Okay, not example 2. Yeah, it's example 2. So example 1 and 2 is about actually original translation. Okay, but we'll see for good translation next time. Okay, this is example 2. Sorry. So sketch the graph of each function. That's the question. Okay, so 2 functions are given. Absolute value x minus 1, and then the other one is f of x is equal to x plus 3 square. Oh, the blurry, right? Sorry. Okay. So now, you see that this is similar to absolute value of x, right? So we know the graph of absolute value of x, which is this, right? X axis, y axis. Let's say this graph of, let's say, let me use a letter G to represent the absolute value function. Okay, absolute value of x. Okay, and now what? The f of x, then the f of x is nothing but what? G of x minus 1, right? We know the graph of g of x. Don't be confused, f and g, okay? So we know the graph of g of x, which is absolute value function, okay? This is known, okay? The goal is to plot the graph of f of x using the what? Transformation, okay? Then to use the transformation here, we need to figure out what? This one, or this one, or this, okay? It means that we need to express the f of x in terms of g of x, which is known, okay? Whose graph is known, I mean, okay? So now, so yeah, I expressed the f of x in terms of g of x, which is g of x minus 1. So now we know the relation between g of x minus 1 and then g of x, I mean graph of g of x and the graph of g of x minus 1. The graph of g of x minus 1 is what? Can be obtained by shifting the graph of g of x to the right 1 unit. Okay, so the 1 unit, right? So now then we move the graph of g of x to the right 1 unit. Okay. So see, and then this one too. Okay. So right here. Then what about the x plus 3 square? So then we start from the graph of x square function, x square. So graph of x square is what? This, right? Y-axis, x-axis. Okay. So see, then the f of x is equal to g of x plus 3, right? So now I think you understood, okay, how we got the relationship between the graph of function, which is known, with the uh, the function what we want to plot. Okay. So now f of x is equal to g of x plus 3. So g of x plus 3 and the g of x, what we get this one, the graph of this one by shifting the graph of g of x to the left 3 unit, right? 3 unit, 3 unit. So here's a 0, right? 1, 2, 3, negative 3. The graph is like this. Okay. So that's for today. Okay. So I'll continue to cover 2.3 next time. I definitely I can finish that. So see.